Good morning, one and all. Welcome to the fourth semester of BTech Electrical and Electronics Engineering. Myself is dealing with the subjects Digital Circuits, which is in the fourth semester of BTech Electrical and Electronics Engineering. Myself, Mr. Jim George, working as Assistant Professor in the Department of Electrical and Electronics Engineering at Muthoot Institute of Technology and Science. So let us move further. So my first question, what is basically an electronics, what is basically a digital circuit? Digital circuits are circuits which is dealing with the signals restricted to the extreme limits of 0 and some full amount. That means, see here we are having 0 and 1. Suppose you are having a continuous signal. Generally in all the circuits we are having analog input signal. So this is an analog input signal with time base, okay, and this is the amplitude. Now suppose I am having a voltage, say here the minimum voltage is say 1 volt and maximum voltage is 5 volt. See, I am taking a median voltage, say 3.5 volt I am taking a median voltage. Now if the values which is less than 3.5 volt I am taking as 0, and values above greater than 3.5 volt I am taking it as 1. Then such kind of representation is used in digital circuits. Okay. Now coming into some more detail about that. If you remember if you are having that digital to DAC and ADC. Okay. So what is basically digital? What is basically DAC card? DAC means digital acquisition or data acquisition. Okay. Now in this data acquisition card, what happens is that the analog data is fed into the card. We are having a card structure. This way we are having a card. Okay. The analog data is fed into the card. And here what happens is that the data which is coming out is in digital form. Okay. So this data acquisition card is basically a analog to digital converter. Okay. So here I am going to mention about analog to digital converter as well as digital to analog converter used in signal processing applications. Now, what is done by data acquisition? What is done by ADC? ADC means analog to digital conversion. Okay, that is what I have mentioned in the earlier figure, that if I am having a continuous voltage like this, say this is 5 volt. And you are having 1 volt, some median voltage I am having 3.5 volt. This is time base and this is the amplitude. If the voltage is less than 3.5 volt is set to 0 and voltage greater than 3.5 volt is taken as 1, then such kind of representation is known as digital representation. This conversion based on some threshold level. Is performed by the analog to digital conversion circuit. Okay. The exact reverse operation is done by DAC, that is digital to analog conversion block. Okay. So that is, now see, presently in the present days, why we are going for this digital circuits? It is because the ease of use. Because here we are having bit type memory. The continuous data in this form is very difficult to very difficult to be fed into the memory of a computer system. So that is why you are going for ADC and DAC. Okay. Now coming into the next part. Okay. What is done by digital electronics? Digital electronics is a field of electronics in which study of digital signals and the engineering devices that use or produce them. That is a study of digital circuits. Now, digital electronic circuits are usually made from large assemblies of logic gates, often packaged as integrated circuits. Now, a broad view of digital circuits is shown here. Yeah. So, digital circuits is used to perform combination operations with basic gates and sequential operations with flip-flops. So here in our subject we are dealing with this part, that is digital circuit, some combination operations using, then how to perform the basic gate operations, then we are having the sequential operations and flip-flops. Then for that, what we need to do, we need to invoke the digital logic, and we need to know the theorems of Boolean algebra and what are the logic families. We have TTL and CMOS logic families. Then that is implemented as integrated circuits. Now coming into where the application is. The application of digital circuits is for data collection and control, which is involving ADC as well as DAC. That is what which I have mentioned. So this track stands for the application part. Okay. Then what are the specialties of this digital circuit? It has the characteristics of basic vocabulary, number system. Okay. So we are having different kinds of number systems like decimal system, decimal number system, binary number system, octal number system, and hexadecimal number system. We will be dealing with all these four kinds of a number system. Then why that is used? That kind of number systems are used for alphanumeric coding. Maybe you have heard about this ASCII code, Gray code, etc. Okay. So here that is used for end-to-end encryption. Okay. So these kind of codes are used for end-to-end encryption and decryption. Okay. So here I have used the word cryptography or encryption or cryptography. Cryptography is used for masking. Masking means if a sender is there and receiver is there, only sender and receiver knows the data, whereas the between entity, the person in between should not be able to read the data. So that is known as encrypting and decrypting. Okay. Why that is used? That is used for communication. Okay. This is an overview of digital circuits. Okay. Now coming to our topic. Our topic is our syllabus consists of 5 modules. In module 1 and 2, we will be dealing with we will be starting with number systems, codes and Boolean logic, and here also we will be dealing with codes also. Codes and Boolean logic. And again we will be dealing with one more thing in module 1, that is this one, we will be dealing with logic families. We will be dealing with logic families in module 1. That is logic families. We have the logic families also here. Okay. And in module from module second half of module 2 and 3, we will be dealing with combination circuit. How to design a combination circuit and how to implement it using minimum number. And we will be introducing to you about Karnaugh maps. We will have Karnaugh maps or K maps. Okay, that is a Karnaugh maps is a powerful technique to reduce the complexity of the circuit, complexity of the data circuit which you are forming. Then in 4 and 5 modules we will be going to sequence circuit like a counter, shift register. Then we will be having counters and shift registers. Counters and shift registers are there. And in the last module we will be dealing with the programmable logic devices like programmable logic array, programmable array logic, and we will have some programming. We will have the introduction to programming of VHDL. So this is an overview of your subject. Now, the objective of the course is to provide a strong foundation of digital logic, including combinational and sequential circuit. That is the objective of this course. This is the objective which you need to satisfy after this course. So the problem statement is already defined. Now, what are the expected outcomes after studying this course? So we have identify from the first module, and by studying first module you should identify what is a number system, what is binary code, and formulate digital functions using Boolean algebra. Now we have a second outcome you should have is design and implement combinational logic circuits. Third outcome you should be able to grab is design and implement sequential logic circuits. That means here I am having a link with the digital lab also. Since you are doing the lab in this semester, you will be able to get this one, design and implementation part also you will get. Then in the fourth outcome you have to compare the operation of analog to digital ADC and DAC, analog to digital conversion and digital to analog conversion. There are various kinds of ADCs available as well as various types of DACs available. So you will be able to compare what is ADC and DAC. Then what is the basic concept of VHDL, that is VHDL programming. Okay. So that is area that is a proposed course outcome. Okay. So now coming to some detailing about this module 1. In module 1 you have number systems and codes. First, then we will study about what are the 3 different types of, 4 are there. One is decimal, binary. Decimal I have forgot here. We have decimal number system, binary number system, octal number system, and hexadecimal number system, and how to convert between these decimal, binary, octal, and hexadecimal systems. That is the first part of our lecture. Then coming into codes, that is ASCII code, HS3 code, gray code, BCD code. Then error detecting code. Okay, this error detecting code is an introduction to cryptography. Okay. Now here we are having the parity method. Then sign numbers, how to represent. We are having positive numbers as well as negative numbers. How to represent the sign numbers. Then addition and subtraction of that, including fixed point and floating point. That means we have decimal numbers also. That means numbers with the decimal points is also included here. The second part is this part. This part is basically the detailed and CMOS logic part, that is the logic family part, that we will keep to the last of our subject. Logic family we will keep to the last of our subject. And here in the second part of module 1, initially we will introduce what is the logic gates, what are the types of, what are the 5 logic gates we are having, then out of them which are the universal gates. Now in module 2 we will go deeper into the subject. What is the Boolean? What are the Boolean laws you need to study? What are the Boolean laws available? Here we are having SOP and POS forms, sum of products and product of sum forms. Again you are having standard sum of products, standard SOP and standard POS forms. That is sum of product and product of sum forms. Then we will go with K-map representation. We have, but here there is a limitation for us. We need to study up to 4 variables, because if you are going to 5 variables, you need to construct more than one K-map to reduce one expression. So in our area of interest, we are limiting our K-map representation to 4 variables. How to design how we have pairs, quads, octet, and how to deal with these don't care conditions. Then after that we will go with the combination. Here we are having the start of combination circuit. The combination circuit we are having is adder, subtractor, adder and subtractor. In adders we are having full adder and half adder. In subtractor also we are having full subtractor and half subtractor. Then the last one we are having is 4-bit binary adder, subtractor as well as carry lookup adder. These are topics in module 2. Then module 3 is comparatively having less number of topics to study. What is comparators? What is package generator and checker? A circuit for package generator and checker. Encoders, decoders, and BCD to 7-second decoder. Okay. Then code converters. That means how to convert gray code to SS3 code. Then like that. Then how to develop the circuit for that. Develop digital circuit for code converters. Then we will be studying about what is a multiplexer and demultiplexer and a basic block diagram of arithmetic logic unit. Module 4 we will be dealing with sequential circuits. Okay. In module 4 we will be dealing with sequential circuits. Okay. The basic elements of a sequential circuit are flip-flops. We are having 4 types of flip-flops: set reset flip-flop, JK flip-flop, D for delay, and T for toggle. We are having SR, JK, D and T flip-flops. Then JK, we are having JK master slave flip-flop. Then what is the importance of reset and clear inputs given the flip-flop? Okay, flip-flop means suppose you are having a 0 to 1 and 1 to 0. Okay, so that is known as flipping and flopping. So conversion from 0 to 1, 1 to 0, or in a reverse order, that is known as flip-flop. That means here the major advantage is that at one time the circuit has output 1 and the next time it will be 0. That is known as flipping and flopping. Okay. Now after that we will deal with asynchronous counters. We are having what is in the modulus of a counter, and mod n counter means mod 10. Mod 10 means you need to count up to 9. Mod 11 means you can count up to 10. That means 0 to 10. We are having 11 numbers. Okay, so that is known as how to design modern counters in synchronous as well as asynchronous mode. We are having synchronous and asynchronous counters. Then after that we will be going with shift register. That means we are having serial in, serial out, serial in, parallel out, parallel in, serial out, and parallel in, parallel out shift registers. Now we are having shift register counters, that is ring counter and Johnson counter. So we need to study only up to 4-bit ring counter and Johnson counter. Now in the last module we are having state machines. Then what is state machines? We are having more and media machines. Then digital to analog converter circuit. Then specifications of this one. Here we are having DAC. DAC we are having weighted resistor type, R2R adder type. And analog to digital converter we are having flash type and successive approximation type and its comparison. Then what are the programmable logic devices we are having? That is PL, that is programmable array logic and programmable logic array. That are the programmable logic devices which we are going to deal with. Then FPGA is field programmable gate array. What is the basic circuit of PAL, PLA and FPGA? Then at last we will be starting with some Verilog programming and implementation of AND or half adder and full adder using Verilog programming. So this is an overview about the subject and the modules which you are going to deal with. The textbooks which I will be using is Freud, Routh, Morris Manor, Anand Kumar. Okay. And sometimes I will refer to Roy Chaudhary is not required here because it is LIC. Okay. But some concept you can take from LIC and Sarivahanan. These are the important textbooks which you need to follow. And some more reference book, that is Donald P. Leitch, Tosi, John of Berkeley and Top. So these are some reference books. And if you are going into SWAYAM courses or NPTEL courses, the course ID of this basic digital electronic circuit is given as online courses nptel.ac.in at NOC 21-E10. That gives the course for digital circuits. So these are the materials which I am providing. Okay. So Okay, thank you for watching this lecture, and in the next class we will start with module 1. So initially we will be starting with the number systems, and we will go with the further lectures. So my aim is to complete the entire subject in 45 to 50 lectures. Okay. So and to have a structure of this subject, after every 3 lectures we will be having quiz of 15 questions, and you have to submit it on time, and you will be having internal exams also on the track. And meanwhile, since the lab and since the digital lab and digital electronics are going in parallel, some classes I will try to take along with the lab. Okay. So thank you for listening. So hope you to see from the starting of this semester onwards. Thank you.